This is test 62, game 4. This is the witnesses trial game. It's an ordering game. We know this, of course, because the witnesses are testifying one by one. So there's an inherent order in which they testify. Now, I've laid out a bunch of rules here, but I'm going to explain all of those. We've got the 6 variables MRSTUW and the 6 spaces for the witnesses. We know that S is immediately before either T or U, so S is before T/U, at least one of those two things. U is earlier than both R and W, and then either T or W is immediately before M. So for that reason, M cannot be last because U is before both R and W. R and W can't be first. U can't be on 6, and of course, U also can't be on 5 because it's before both R and W. We know that S is immediately before at least one of S is immediately before T or U, so for that reason, S is not on 6. So these are just some initial bare bones inferences we can use. No easy way to really link these together due to the ambiguities in TU and the ambiguities in TW. So for that reason, I would simply move on immediately to the question. So number 19 is a typical orientation question. Just take one rule at a time and apply that rule to all 5 choices looking for violations. So a simple one to look for is that U's before both R and W. We see that choice E violates this, having U after both of them, so E's gone. We also see that A violates this, having U after R, so A is gone as well. We can also use these 2 box rules here. We know that S is immediately before either T or U. D violates this, so D is gone. And then we can look for M immediately after one of TW, and C violates it, so that's gone, leaving B by elimination for number 19. Next, number 20, if T was first, what could be true? So if T is first, we know that T is not immediately after S, meaning that U is immediately after S, giving us a larger chain, as is before U, which is before both R and W. So with this knowledge, we can run, and of course S is immediately before U, so I can actually box that right there. S is immediately before U, which is before both R and W. So R could not be second because S and U both have to come before it, so A is gone. Could W be third? No, because at least S and U have to come before it, and T even before that on 1, so B is gone. Next we got S on 4. Could that be the case? No, if S was on 4, we'd have U on 5, and then only one of RW coming afterwards, not both, due to this sequence here. So for that reason, C is gone. U on 5 wouldn't work because it never works. We got to have both R and W after it, and U on 5 only allows one of those things to occur. So D is gone, leaving E by elimination for number 20. Next, number 21, if S was on 5. So if S is on 5, we know that T is going to have to be on 6. U couldn't be on 6 because it never is due to the fact that R and W both have to come after it. So now that ST is happening, we know that we got U over here, T is not immediately before M, therefore W is. So we have W immediately before M, as well as U coming before that, and U is also before R as always. I'm just kind of combining these two things together with the knowledge that W and M are joined rather than T and M being joined. So what happens now? Well, U is before everybody else that remains. So for that reason, U has to be on 1, and then we have R as well as WM occurring somewhere within the spaces of 2, 3, and 4. So for that reason, U on first, choice A is our answer to number 21. Next, number 22, which pairing of people cannot be on both 3 and 4 respectively, meaning in that order? No immediately apparent way to attack the choices here, just run through them one at a time. So we'll look at A, M and T on 3 and 4. Could that work? Well, we're certainly not going to have TM here because T's after M. We'd have to have WM. Now we can't have ST, of course, so we'd have to have SU. Now we know that S is immediately before U, W is immediately before M, of course, in this case. Now U is before both R and W, so I'll put R and W coming after this. Now the problem is that there is no room for WM to occur. WM would have to occur on 2, 3, of course, so that's taken out of the picture. But W's got to come after SU, and there's no room for that because S and U cannot both fit on 1. So for that reason, M and T on 3 and 4 leads us to an impossible state of affairs, therefore it cannot happen. So A is our answer for 22 and no need to run through the rest. Next, number 23, which pairing of people cannot be first and second? So of course this question is very similar to the one that we just previously encountered. Again, no immediately apparent way to attack the choices here, just you want to run through them one at a time. And you'll see that A, B, and C all work out perfectly fine. However, choice D, UT, does not work, because if we had U on 1 and T on 2, we certainly wouldn't be able to have ST. Instead, we'd have to have SU. So I'm going to cross off the T here since we're not having ST. But SU is a problem, of course, because there is no room for S to come before U, given that U is on 1. So for that reason, S coming before U is impossible. So UT on 1 and 2 respectively is impossible, and therefore D is our answer to number 23.